In this video, we will review what bag of words means. By the end of this video, you should be able to explain what bag of words mean, understand how you can build machine learning features from words, and give examples of stop words. Bag of words model is a very simple representation of a body of text as a loose set of words. It flattens any text into an unordered collection of words. Although it disregards the sentence structure associated to the words, this simple technique is pretty useful to identify a topic or sentiment in text, like if a product review has a negative or positive sentiment, or what a body of text talks about. We can use the words in a feature matrix, where each word is a column and each text body or review in our movie example is a row that has Boolean data values. A cell in the review row gets assigned true if the word appears in the review and false if it doesn't. Just by looking at these three rows in this matrix with a limited set of words, we can identify that the topic of these reviews are movies, and probably review 1 and review 3 are positive, and review 2 is negative. Before we move on to our notebook, I would like to mention that it is often practiced to filter our stop words and maybe even the punctuations from the bag of words before further analysis. Stop words are words like the, that, and is, which occur a lot, but don't have a big significance in identifying the context of the text being processed. Now, let's switch back to our notebook to execute our first bag of words model. As we just overviewed, from the bag of words model, we can build features to be used by a classifier. And here we assume that each word is a feature that can either be true or false. We implement this in Python as a dictionary, where each word in a sentence we associate with true, and if a word is missing, that would be the same as assigning false, or in this case, we won't have anything. So let's do this for loop. Word is true for word in Romeo words. So we'll have as you see here, a dictionary where each word in Romeo words are assigned a true. And there are no false values because we are not assigning false for anything. You would remember from our earlier videos is this underscore here is the last output that goes into the standard out in this shell. So if you had assigned that dictionary to a variable, you need to write the name of that variable within this type. Okay, to generalize what we did, this creation of this dictionary here, we can turn what we've done here into a Python function. In this code cell here, we define a Python function. And next, we will use it. Let's execute this Python function. It's called build underscore bag underscore of underscore words underscore features. So we are building a bag of words features for the words that we just created as a dictionary. So this function will accept a dictionary, or will accept a set of words and return a dictionary for it. So let's run the function and see if we get that same output with what we've just inlined. Great, we get the same output. This is what we wanted, but notice here, punctuations like exclamation mark or comma or dot are still showing up. And those are useless for classification purposes. Similarly, we have words like of, that, or is, or in. Those don't need to be included. So those words are named stop words, and NLTK actually has a corpus of them for each language, or in this case, English. So we can actually download the stop words from NLTK. We can now use the stop words in English and punctuation characters in the string class, which are these characters that are listed in our out24 line. We can use this to create a list of what we don't want. We'll call this list useless words. Here, I create useless words as a list, and it's a combination of stop words for English and the punctuation characters. If you're having maybe curiosity or maybe not completely understanding what stop words are, please feel free to print out the stop words that are here in the NLTK corpus stop words English to explore with those words a little bit and see what those words are. We can, of course, now uncomment useless words and see the list ourselves here. So there are I, me, my, myself, and the list goes onwards from there. So for simplicity, I'll comment out that line and run this again. Now we will actually update our bag of words function that we built with an if statement to check if the word exists in useless words and skip that word if it does. So we have the same function, word. It was true before, now it's 1 for word in words, but there we have a condition, if not, word in useless words. So it means if the word is not in useless words, add that to our dictionary. As you might have noticed, instead of true as a value for the word, here we are using 1 in this new function. Let's run our function. And now we'll use this function, build bag of words features filtered, features being the useless words filtered, to give it the Romeo words as input. So if we do that, we see that the punctuation and some of those stop words that we had above are gone, and we have a cleaner list of words in our dictionary. We are making progress. Next, let's see how we can calculate and plot the frequencies of words in this list.